Okay, so little fact to start off with. Complementary angles. What are they? Shaker, you go. That's supplementary angles. Close. Gabe? 90 degrees, yeah. Otherwise known as? Yeah, or pi on 2. Yeah, right angle or pi on 2. So complementary angles are angles that sum to pi on 2. Now, if you think about what we've done so far, all of our work has been around taking an angle plus or minus one of the x-axes. So pi, or 0, obviously, or pi, or 2 pi, or 3 pi, or 4 pi, etc. So if we've got sine of x is equal to 0.6, then we're looking at what is the sine of pi minus x, or what is sine of pi plus x, or what is sine of 2 pi plus x. Whatever it is, it's always going from the x-axis, and that effectively gets us into supplementary angle territory ultimately. But what happens if we're asked what is the sine of pi on 2 minus x? In other words, we're taking the angle away from the y-axis instead of taking the angle away from the x-axis. Well, that's a complementary angles result. And in order to move us forward from here, I'm going to give you a couple of examples and illustrate how we deal with them. And it brings out a result that I want you to be aware of, even though we're not necessarily going to use it a lot. So you might remember that I said we need to hold on to our understanding that sine theta is effectively the y-coordinate and cosine of an angle is effectively the x-coordinate, and the angle is always taken from the x-axis, like so. So when the angle is taken from the x-axis, we have cos of theta here, the x-coordinate, and sine of theta here, the y-coordinate. Okay, good so far? All right. So if theta is acute, I won't even get you to guess what I'm looking for here. If theta is acute, then theta and pi on 2 minus theta are complementary angles. There's a relationship there between those two. Don't get caught up with the idea that this is something magical. It is just an angle. Let me show you what I mean. 60 and what are complementary angles? 60 degrees and what are complementary angles? 30 degrees. 1 degree and 89 degrees are complementary angles. 1 and 90 minus 1 are complementary angles. 60 and 90 minus 60 are complementary angles. That's all this means. These are just two angles hanging out together. You know, that's all they are. Okay? Really important. Don't get caught up with the fact that the algebra is not a single letter or variable. Alrighty, so we're going to have a look at an example straight up. Sine of theta is 3/5. That's what we're given. And, importantly, we're told that theta is an acute angle. It's between 0 and pi on 2. And we're asked to find sine of pi on 2 minus theta. Okay, so first of all, let's focus on theta itself. Might even do a zoom here. If I focus on theta itself, on my unit circle, and I go like this, like so, then I can put a dot down here to make my right angle triangle, and I'm going to use my 3/5 at this point. Now, people, last lesson, we saw the Pythagorean identity, sine squared plus cos squared equals 1. We could 100% use this as well, but we're not going to, because the process I'm going to take you through now is quite a powerful one for solving lots of different problems. So rather than using Pythagorean identity, I am going to use the properties of sine, basic properties in a right angle. If this was a right angle triangle, The 3 would be the length of the which side? Sokoto. Which side? Thank you. So there's theta. So therefore the opposite side, I'll do it in this colour, is 3. And what would the 5 be? Hello. 5 there. Notice I'm leaving them spaced out a bit. There's a reason for that. So what does that make this side here? Now, I'm not even going to put an arrow there actually, because I'm going to try and emulate what I would do. What I would do is I would think about this. I've got this, your old pal Pythagoras' theorem, and I can use it to work out that unknown side. That unknown side would be the square root of 5 squared minus 3 squared. What do you think about that? Yep. So that would be 25 minus 9. That would be 16. So that would be 4. You okay with that? Also, you should know your Pythagorean triples enough to go, that's a 3, 4, 5 triangle. I say should. It doesn't matter that you don't. 3, 4, 5. What's another one? 5, 12, 13? Probably the 2 most common ones. So when you see a 3 and a 5, knowing that the other side is a 4 is nice to know. So 3, 4, 5, done. Okay, so we now have a triangle with a 3 and a 4 and a 5. However, in the unit circle, we don't have a hypotenuse of 5. We have a hypotenuse of 1. So what I'm going to do is I'll just put it in a different colour so you can see it, but you don't have to do it in a different colour. I'm going to divide each of the sides by 5. In other words, I'm finding the appropriate size triangle. I've scaled all the sides down. So I've divided each side by 5. So in other words, I've got a hypotenuse of 1. I've got 3/5 as my opposite side and 4/5 as my adjacent side. And my coordinates, of course, are, whoops, wrong way around, 4/5, 3/5. That's my coordinates, yeah? 4/5 my x coordinate, 3/5 my y coordinate. Okay, and that makes sense because we know that the y coordinate is the sine, and sine of theta equals 3/5. So this all matches with all of our understanding of the unit circle thus far. Questions before I move on? Yep. No, well, yes, and the biggest number is always the hypotenuse, yeah? It's always the biggest side of a right angle. So you always divide by the hypotenuse because what we want is a hypotenuse of 1. It's also the biggest number. Yeah. Thanks, Sonny. Anything else? Okay, so we're going to use 1 instead of 5/5 from now on. But we're not interested, of course, in the sine of theta. We're interested in the sine of pi on 2 minus theta. So I'll have to leave that zoomed out, I think, for this next bit, but I will write fairly big. So if I go sine of 2 minus theta, remember, always from the x-axis. Is that too big? That's too big. All right, it's doing all scribbles everywhere. I don't want it to be confusing. If I look at it from the sine of pi on 2 minus theta, what have I got? I've got this right angle triangle here. This angle here is pi on 2 minus theta. So what does that make the angle here? Starts with th and rhymes with beta. Sorry? Theta. So that's got to be theta in there. Does that make sense? This whole thing is right angled. I'm asked to find the sine of pi on 2 minus theta. That has to be this big old angle here. That means this bit left over here must be just theta. If I add those two together, I'm going to get 90 degrees, aren't I? Minus theta plus theta cancels out, leaves me with pi on 2. Please tell me you understand before I move on. I always get worried. Okay, if you look at it, this triangle here and this triangle here are the same but rotated. Yeah, because it's the same angle here. and it's the same length here of 1. So if I just pop in a little dotted line here to finish off that triangle, then this has a length of 1 here. This little edge here is now this edge here. I'm so sorry. I think I need to just reduce my pen size so it's not as smudgy. Oh, that's better. That's 3/5 there, and this has to be 4/5 up here, right? So all I've done is I've transposed. I've said, well, this hypotenuse of 5 on 5, 1, is here. This little side here, opposite theta, is 3/5, and here, opposite theta, is 3/5. And this side here, which is adjacent to theta, 4/5, is now adjacent to theta, but it's up here instead. So we've transposed each of them. These are two identical triangles, effectively, just rotated around. Questions before I move on? Because if you don't get this, the rest of it is going to be, I might as well be just writing in hieroglyphics from now on. Ask questions. Yes. Okay, that's good to start. If I draw a triangle out, ignore these two triangles, just using this little space here. If I draw a triangle out with an angle of theta here, and then I draw it like this, and this is theta here as well, if this side length, sorry, where's my right angle? There. Sorry, that's bad. I'll just do that again. I can rotate, I can't really show you very well, but I'll stand up and do it, so it's not good for the video, but I can effectively flip that triangle over like that. So I'm physically, where the hypotenuse of 1 is, I'm flipping the triangle over, okay? That would make it look like this if I flipped it. And theta would still be there in the corner. So if I flipped it, it's the same triangle. I'm just flipping it over. And now I'm going to flip it upways. I'm going to flip. So now I'm going to flip it upways instead, and that will get me a longer looking triangle that way, theta. But this side, which got flipped over to here, is now flipped to here. Okay, so I have flipped. This triangle has been flipped. Well, it's been switched like that and then flipped over like that. So rotated and then flipped. Rotated and then flipped. But it's the same size triangle. That's the critical thing. Flip. So rotate. That's probably better than what I just did a second ago. Rotate, then flip. Well, I'm not saying that that's... So what I'm saying is that because I've got the hypotenuse as being 1, the same in this triangle here, and because pi on 2 minus theta gives us the same angle in here as was in here, the rest of the sides must be the same lengths as well. Is that okay? Theta matches up. The hypotenuse match up. And so these other two side lengths must be the same as well. We just need to figure out its positioning. This little length here would be flipped up to here. Why? Because theta is opposite this side, which is 3/5. And in this triangle here, which is the identical size triangle, in this triangle here, opposite is 3/5 here. This length here of 4/5, which is next to the theta angle, just becomes next to it, but over here instead, 4/5. So if you don't understand the why, I'll come back and talk to people individually. So I want you to sort of see it just as this then. These two are identical triangles. They are. All you're doing then is you're matching sides to the same positions in this different triangle here. So in this triangle, 3/5 is opposite theta. In this triangle, it is also opposite theta. In this triangle, 4/5 is adjacent to theta. In this triangle, it is also adjacent to theta. If I put 4/5 up here, it would be opposite, and it's not opposite there. So they occupy the same relative positions as they did in the original triangle. Now, yeah, you see now, if you don't understand why and you want to, that's fine. I'll come back and talk to you, but I won't slow down at this point. So I'll just tie that together again and move on. What I'm saying is that we have been asked to find sine of pi on 2 minus theta. That's what we've been asked to find. Pi on 2 minus theta would be here somewhere. Maybe it's down here or maybe it's up here. It doesn't matter. This is just an illustration. If this angle here is pi on 2 minus theta, then it must be that between the y-axis and the unit line, this little line here must be theta here. And hence we have our two triangles. Now, what does that mean in terms of the coordinates? It means that the coordinates are the x-coordinate, which is 3/5, the distance this way, and the y-coordinate, which is 4/5, which is the distance upways. And so that means that sine pi on 2 minus theta is equal to the y-coordinate in the first quadrant, so it's positive, so it's 4/5. So we're just looking at the y-coordinate because it was sine. If we were looking for the cosine, we'd be looking at the x-coordinate. Now, I've got one more thing to say after that, but I just want to check to make sure that you're okay with that. Asking questions, etc., etc. Now, have a look at this original triangle here. What is, using this triangle here only, what is the cosine of theta? Yes, it's 4/5, because the triangle tells us it's adjacent over hypotenuse, 4/5 over 1, and also it's the x-coordinate. So we have a result here that we can use, which is that sine of pi on 2 minus theta is equal to the cosine of theta if it's in the first quadrant. Okay? Now, we're going to try a harder example. In this example, it is harder because although we've got the same ratio, the same value for sine theta, 3/5, we've now got theta between pi on 2 and pi, so it's an obtuse angle. And we're asked to find the sine of 3 pi on 2 minus theta. Now, again, this bit here tells us that we are going from a y-axis, 0, pi on 2, pi, 3 pi on 2, 2 pi, 5 pi on 2, etc. Okay, so we're going from a y-axis. So we need to use our complementary angle relations. Personally, though, I think it's a lot easier if we just think about what's happening. We're subtracting an obtuse angle away from the y-axis. So let's see this in action. So number one, let's consider just the obtuse angle. What's happening in the obtuse angle? So if I look at the sine of theta, which is the fact that I'm given, I'm using the fact that I've got in order to work out extra facts. So if I'm looking at the fact that I'm given, if I draw out sine of theta, I'm trying hard not to do a 45-degree angle because it's confusing when it's 45. That's why I try to make it thinner or fatter so it really stands out. So there is theta. And if you might remember that I've used theta hat to describe the little inside acute angle. Okay, and we know that sine theta is the same as sine theta hat, and then we just need to apply the right SIGN plus or minus for the quadrant. And we said that sine theta equals 3/5. That makes sense because even though it's in the second quadrant, sine is positive. So that's okay as well. What we have is in this triangle, we're going to do the same thing again. Opposite over hypotenuse is sine. So that's going to be 3 over here and 5 over here. And for the same kind of calculation basis, we've got a length of 4. And if we divide each side by the hypotenuse, we get our lengths there of 3/5, 4/5, and 5/5. And we will have, I'll get rid of that 1 because it's going to get in the way. And then we'll have our coordinates of negative 4/5 and positive 3/5. Okay, so I'm just looking at my my understanding of sine theta so I can fill out all the sides of the triangle. Everyone okay with that? Cool. Step 2. We then consider, again, this is going to be hard for me to capture on video, but we'll give it a crack. We then consider what 3 pi on 2 minus theta equals. 3 pi on 2 is all the way over here, yes? That's 3 pi on 2. But then we're going to subtract theta, and theta is an obtuse angle. So have a look at this and sort of turn it on its side. You can see that we're going to go backwards, but we're going to pass through one quadrant and then land in the next quadrant across. So backwards would look like this. Somewhere like that. Okay? So this angle here is theta. I've gone backwards that much. This angle here is 3 pi on 2 minus theta because theta is an obtuse angle. And so what do we have left in here? Starts with theta and ends in hat. What do we have in here? Theta hat. Okay, because, and again, hard to capture. Oh, that's a bit too small. There we go. Hard to capture, so I'll be doing it verbally and visually on the board. Effectively, if I take that and kind of rotate and flip it, if theta is all that way and then theta hat is that little bit of distance here, if I do it from this point starting, then if theta is all the way here, then this has got to be theta hat here as well. Okay, it's going to be the same size as this, but we've just flipped it around. It's the same size. So I'm going to label that with theta hat, and I'm going to do the same thing as I did last time. I've got theta hat here. I'm going to make my right angle triangle here, and I'm going to look at the corresponding values. So we've got theta, opposite theta hat is this little side here. Opposite theta hat is 3/5. So I can fill in 3/5. Adjacent to theta hat is this length here. Adjacent to theta hat is 4/5. So we've got 4/5 here. And so our coordinate up here is going to be negative 3/5 because we're going backwards, and positive 4/5 because we're going upways. So our coordinates are minus 3/5 and 4/5. So we've done our match. And again, this is the point that we're finishing off with. And so we're asking ourselves, well, what's the y coordinate of that? Because the y coordinate, I would never write y coordinate. I'm just doing it for the notes. So the y coordinate is what the sine value is of 3 pi on 2 minus theta, and that is equal to 4/5. Okay? So we are just looking at the y coordinate. If I was asked what the cosine of 3 pi on 2 minus theta is, I've now got a diagram that I can answer straight up. It's minus 3/5. If I was asked what the tan was, I would just divide rise over run, so it would be 4 over negative 3. It would be negative 1 1/3. So you can answer everything from that diagram as long as you understand y coordinate for sine, x coordinate for cosine, and divide one by the other for tan. I've got one more example to show you, but I wanted to see if there are any questions on that. I promise you, part of this is going to be practice, where if you just follow my steps through and you repeat them problem after a problem, you will get there in the end. You might notice again that 4/5 is the value of cosine as well, but it doesn't always go, it's just cosine of theta. It does, but the signage does sometimes change, where it might be negative cosine of theta and so on. It will always be cosine of theta, but you have to work out whether it's plus or minus. That's where it gets a bit tricky. Okay, here's example 3. Sorry? Example 3 is actually no harder than example 2. I'm just doing a lot more of a twist. So example 3, this is when you get the track of it, you'll be okay, trust me. So for example 3, we have sine of theta equals negative root 5 on 3, and theta is between 3 pi on 2 and 2 pi. In other words, it's a reflex angle all the way around. So first of all, I draw up my unit circle axes, and I put in where I know the line will end up, trying to desperately to not make it a 45-degree angle, because then everything looks a bit weird. So this angle here is 3 pi. This angle here is theta. It's an angle that's between 3 pi on 2 and 2 pi. Don't know what the angle is, so I just exaggerated it to make sure it's there. Because remember, the angle is always from the x-axis. And then here, we're going to have our old friend theta hat back. I'm going to zoom up so you can see it. Don't need to see the rest of it yet. So we've got theta hat sandwiched between the x-axis and the unit line, which is 1. Then I'm going to form my right angle triangle, like so, and I'm going to work out opposite, hypotenuse, and adjacent. So straight up, because this is theta hat, we're just looking at lengths, not direction. So I'm going to ignore the negative, and I'm just going to fill in root 5 and 3. So we've got opposite is root 5, and 3 must be the hypotenuse. In your head or off to the side on a piece of paper, you can now work out what the missing side is. It's going to be 3 squared minus root 5 squared and square root the lot. Okay, so it's going to be the square root of 9 minus 5, which is equal to the square root of 4. So we can write down that the missing side length is 2. I'm then going to divide through by 3 because the hypotenuse needs to be 1. So that gives me side lengths of 2/3, root 5 on 3, and 3 on 3, or 1. That makes this coordinate, you don't have to fill it in, but I'm just going to do it for the notes. That makes this coordinate 2/3 in the positive direction and root 5 on 3 in the negative direction, so negative root 5 on 3. This all matches up exactly with what we would expect, because we were given sine theta is minus root 5 on 3, and we can see there's a y coordinate of minus root 5 on 3. Find, evaluate, what do you mean? In the question? Yeah. The question will say find the value of, evaluate, etc. Yeah. Say that again. Okay. Theta, remember, this is sine theta here. This is not this is not the end. We're not done. This is just step 1. Step 1 is, well, what does theta look like? If theta is between 3 pi on 2 and 2 pi, it's going to be pi on 2, pi, 3 pi on 2. It's going to be between here and here. So that's why theta is a 4th quadrant angle. Yeah, that's cool. But does that make sense now? Yeah, cool. Now, so that's the setup. So what I've got there in slide 9 there is the setup. Here is the payoff. Now that we've done the setup, we are now going to examine what 3 pi on 2 minus theta looks like. So I draw my next set of axes. And this bit tells me where to start. I'm starting at 3 pi on 2, so I'm starting from the y-axis. And then minus theta tells me I'm going to go backwards by theta. Now you can see here that to get to this quadrant here, I had to go through 3 quadrants. So I'm going to do the same thing but backwards because it's minus theta. If that was plus theta, I'd go forwards, but it's minus theta, so I'm going backwards. So I'm going to go back 1, back 2, back 3. So this angle here this angle here is theta. I've started off at 3 pi on 2, and I've gone to theta. No. No, because I've landed here. Nope. 1, 2, 3. No, you're right. You're right. Thank you. Yeah, 100% right. Okay, so we've gone 1, that's pi on 2, 2, 3 pi on 2. Pi, that's why I made the mistake last time. 1 is pi on 2, another one is pi, another one is 3 pi on 2, plus a little bit more, gets me between 3 pi on 2 and 2 pi. Thanks, Alex, appreciate that. Okay, so we end up with something like this, just exaggerating for effect. So this is 3 pi, is theta. Yep. Okay, so that's theta. The little bit left over is going to be theta hat. Okay, so it's just the same as this diagram, but effectively rotated around. Okay, we've got a little bit left over, and that becomes theta hat. So now that we've done that, we can transfer over our values to our new triangle. Okay, so we will go opposite theta hat is root 5 on 3. So we fill in root 5 on 3. The hypotenuse, as always, is 1. The adjacent side is 2/3, 2 on 3. So we've now filled in our triangle according to where it now has landed in the 4th quadrant, not the 3rd. Thank you, Alex. My coordinates are going to be root 5 on 3 in the positive x direction and negative 2/3 in the y direction. Okay, so now that we've got our coordinates, knowing that sine is our y coordinate, we can conclude, therefore, the sine of 3 pi on 2 minus theta is equal to negative 2/3. And again, that might feel like it's a lot of work, but often you're asked, what's the cosine? Also, alongside that one, what is the cosine of 3 pi on 2 minus theta? Well, this, you don't need to do any more work. You can just go, well, that's going to be root 5 on 3. What's the tan of 3 pi on 2 minus theta? Just divide one by the other and you'll get minus 2/3. Okay, so the rest of the problem solving from then becomes fairly straightforward. So just to summarize, and then I'll let you get on to work. What have we got? Yeah, not much time. To summarize, what you are doing is you're modeling the angle in whatever quadrant you've been given to work out the 3 sides using Pythagoras' theorem. You are then looking at the actual thing you need to look for, in this case, 3 pi on 2 minus theta, and you're looking at where that gets you, what quadrant that gets you into. You are then transferring your 3 sides to the new triangle, and then you are writing down the y coordinate for sine, the x coordinate for cos, or the gradient rise over run for tan. And that's basically it. There's a fair bit to take on there, I guess, conceptually, but again, practice will get you there. And secondly, if you can't quite get there, it just means that there's a couple of questions you might not be able to do. Right, so for the next 15 minutes or thereabouts, exercise 6C, maybe try every second one. I'll try and give you some more time tomorrow.